Hello and welcome. In this video, we will present the basic functionality of switches. It is important to know how switches function because it will form the foundation for learning more advanced switching concepts such as spanning tree protocol, virtual LANs, and VLAN trunking protocol. Traditional Ethernet that uses a hub rather than a switch is a functional yet inefficient technology. It uses a logical bus topology, which means the hub forwards traffic out all ports to all connected devices, not just the one device to which the frames are addressed. This situation is inefficient because all hosts receive the frames, even if the frames are not meant for them. If a frame is not meant for a specific device, that device discards the frame. Moreover, while frames are on the network is in use and cannot be used by any other devices. This functionality is inefficient because it wastes bandwidth. It also poses a security problem because all devices can read any frame sent to any computer on the hub, even if the frames aren't addressed to them. If two devices try to use the network simultaneously, as seen in this animation, a collision occurs. When a collision occurs, messages become garbled or unreadable, and the network must reset itself before data delivery can again be attempted. The area of the network where a host can receive a garbled message resulting from a collision is called a collision domain. With the introduction of switches, the LAN became more intelligent. When a frame arrives at a switch, the switch examines the destination MAC address field of the frame and forwards the frame out the port connected to the device that has that MAC address, rather than being forwarded to all ports as in the case with a hub. The MAC address table lists the MAC address of the device that is connected to every port on the switch. For example, H1 sends a frame to H8. When the switch receives that frame, it looks at its destination MAC address field and finds that the destination host has a MAC address of 260.8c01.7777. The switch consults its MAC address table and finds that the port that is connected to the device with that MAC address is port FA08. The frame is then forwarded out that port and reaches its intended destination. Because switches use full duplex technology, multiple devices can communicate simultaneously. So in our example, while H1 communicates with H8, H2 can communicate with H3, etc. This is called microsegmentation and is one advantage that switches have over hubs. Switches use available bandwidth very efficiently as compared to hubs. One question you may be asking is, how does the MAC address table learn about port to MAC address mappings? How does the MAC address table become populated with information? MAC tables are populated based on a frame's source address. Let's walk through some steps, assuming that the MAC address table is completely empty. In step 1, the switch receives a frame destined for PC2 on port 3 from PC1. In step 2, when the switch receives the frame, it places the MAC address for PC1 and its associated port in its MAC address table. Notice that the switch does not yet know what port is associated with PC2, the destination of the frame. In step 3, because the switch does not yet know which port PC2 is on, it broadcasts the frame out all ports except port 1, which is connected to the source of the frame. In steps 4 and 5, when the destination, PC2, replies back to PC1, the switch populates the MAC address for PC2 and the port to which it is connected into the MAC address table. At this point, the switch has learned that PC1 is connected to port 1 and PC2 is connected to port 3. Since the switch has now learned the MAC address and associated ports of PCs 1 and 2, if PC1 were to send another message to PC2, the switch would send the frame out the appropriate single port rather than broadcast it out all ports. This is the process that switches use to learn which MAC addresses are connected to specific switch ports. Although beyond the scope of this presentation, there are many other advantages gained by deploying a switched network. However, the bandwidth that is conserved through microsegmentation, which again is the ability of a switch to coordinate multiple point-to-point LAN links simultaneously, is by far the main advantage of a switched network. As always, don't forget to visit www.cisco.com to learn more.